Hey guys, we're going to start a lesson on parallel and perpendicular lines. So go ahead and grab your composition book and write this title at the top. If you need to pause the video for a second while you get everything settled, go ahead and do that, and you'll probably need a calculator. All right, our objective is to be able to determine whether lines are parallel, perpendicular, or neither, and then write equations. So parallel lines have the same slope. So go ahead and write this sentence down. And then look at the picture. The blue line and the red line are parallel. That means their slopes are the same. Their rates of change are the same. All right, example 1. Write an equation of a line in slope-intercept form that passes through 4, 2 and is parallel to the graph of y equals 1/2 x minus 7. Well, they've given me some information to write my line. They've given me a point, so I have my point, which is 4, -2. So there's my point. But I need my slope to write a line. But they want it to be parallel. Well, on the last slide, we just said that parallel lines have the same slope. So I'm going to harvest the slope out of this line. So see that 1/2? I'm going to take it out. And that's all I need that for. I'm done. So the slope of that line was 1/2. So I grab the 1/2, but I'm not going to use this -7. That's a pretty common mistake. A lot of people think you have to use that, but once you grab the 1/2, you're done with that. So now I need slope-intercept form, and slope-intercept form is y equals mx plus b, but I don't have a beginning value. That means I have to use the other equation first. My other equation, try to write it from memory, is y minus y1 equals mx minus x1. Well, I know that my ordered pair is going to be my x1 and my y1. So I have y minus, and then my y1 is -2 equals m, which is 1/2, and then I have x minus, and my x1 is 4. Okay? So be careful here. This y minus -2 changes to y plus 2. Then I'm going to distribute the 1/2. So I have 1/2 x minus 1/2 of 4 is just 2. So then I'm going to subtract 2 from both sides, and I get y equals 1/2 x minus 4. So look at that. These two lines are parallel because look at their slopes. They're both 1/2 because the slope is what goes right in front of the x. All right, moving on to example 2. Write an equation in slope-intercept form for a line that passes through 2, 4 and is parallel to the graph. Okay, so I have my point. So my point is 2, 4. That's going to be my x1 and my y1. But it has to be parallel to this line. Now you can't just grab the 4. You know why? Think about it. Because it's not solved for y. So to get the slope, I can't take the slope unless it's in slope-intercept form, which means solve for y. So I've got to take this equation, 4x plus y equals 5, and I have to solve for y. So I'm going to subtract 4x from both sides, and I get y equals -4x plus 5. See what happened there? When I solve for y, it changed my slope. So my slope is -4. So now I have my point, and I have my slope, and I'm done with this line. I'm done with the one. I have to write a new line, or new equation. So I go to my equation, see if you can write it from memory. Y minus y1 equals m parenthesis x minus x1. So here we go. So I have y minus, I need my y1. So I come over here to my ordered pair and grab the 4. I need my slope, which is my m, which is -4. And then it's x minus, my x1 is 2. Now go ahead and solve for y. So I'm going to just stop talking. You know how to solve for y. We've been doing this for a long time. Just don't forget to distribute the -4 on the right-hand side. All right, did you get the same thing I got? Y equals -4x plus 12. We wanted the lines to be parallel, and look, the slope of my first line was -4x, or -4, and the slope of my second line is -4. So I'm good. All right, we reached checkpoint 1. Go ahead and pause the video and solve this problem, and we will discuss this in class. You're going to find the equation of a line passing through the point that's parallel to this line. So remember, we can't just grab the 3 right now. We have to solve for y to find out what the slope is. So we got to find out what is the slope by solving for y. All right, moving on to perpendicular lines. Perpendicular lines. So the slopes of perpendicular lines are 2 things. They're opposite reciprocals. They're opposite reciprocals. Opposite means the signs are different, and a reciprocal means it's flipped. The fraction is flipped. That looks terrible. The fraction is flipped. There we go. Okay? So the opposite signs, because remember we talked about the slope. This blue line has a positive slope, and for the line to be perpendicular, it's going to go the other way, so it's going to have a negative slope. So they have to be opposite signs. That's the first thing. Then they're going to be reciprocals. So if this is a positive slope of, let's see, what is that one? This is a slope of 1, then the red line is a slope of -1. Okay? You couldn't tell that I flipped the fraction. 1/1 is the same both ways, but we're going to get to some examples where it's not the case. All right, example 3. Write an equation in slope-intercept form for a line that passes through 4, 7 and is perpendicular to this graph. Okay, so I need my point, which is 4, 7. So that's my x1 and my y1. Now, I need to grab the slope out of this line, and since it's solved for y, I can go ahead and grab the slope. So my slope right now is 2/3, but they ask for a perpendicular slope. So this little symbol right here is the perpendicular slope. So for the perpendicular slope, you have to do 2 things. You have to make it opposite. And we talked about opposite being positive versus negative. So my slope that I have here for my m, which is 2/3, is positive. So this has to be negative. And then the reciprocal means flip the fraction. So I get -3/2. So see what I did? The first one was 2/3, so it was positive. My next one had to be negative. And then I flipped the fraction. 2/3 became 3/2. So this is the slope I'm going to use. All right, so now I'm going to plug it into what I know. I know y minus y1 equals mx minus x1. That's my point slope form. And that's what I have. I have a point and I have a slope. So that's the only form I can use at this point. So I'm going to plug in y minus my y1. Go ahead and grab it there. And then I need my m. Go ahead and grab your m, the perpendicular one. Did you get the right one? And then I have x minus, my x1 is 4. Excuse me. Excuse me. So then I have y minus 7 equals, I need to distribute. Don't fear the fraction. I have -3/2 x. Then a negative times a negative is a positive. And then when I multiply this, I get 6. -3/2 times -4 is 6. So one last step is solving for, or adding 7 to both sides to solve for y. So I get -3/2 x plus 13. Done. Go ahead and pause the video if you need to look over that for a few more minutes. All right, moving on to example 5. Write an equation in slope-intercept form, that means solve for y, for the line that passes through this point, 4, -1, and is perpendicular to this line. Ooh, that's not solve for y, so I got to be careful. So right now I already know my point, so that's 4, -1. So this is my x1 and my y1. I have to solve for y to get that slope. So I have 7x minus 2y equals 3. I have to solve for y. So I'm going to subtract 7x from both sides. So I get -2y equals -7x plus 3. Then I divide by -2 on each term. So I get y equals, a negative divided by a negative is a positive, so I get 7/2 x minus 3/2. Okay, I can just leave it like that because the only thing I really care about is the slope. So my slope right now is 7/2. but they want it to be perpendicular. So that means I have to do two things to it. So my perpendicular slope, I have to do two things. First, I have to make the signs opposite. So my original slope was positive, so I'm going to make my new one negative, and then I have to flip the fraction. So I get negative 2/7. So this is the slope I'm going to use, and this is the point I'm going to use. So if I have point and slope, I have to use point-slope form, which is this one. Y minus y1 equals mx minus x1. So I start substituting. I have y minus, my y1 is negative 1, then my m is negative 2/7, and then I have x minus 4. Now be careful with that minus minus, it's really just y plus 1 equals, then I have negative 2/7 x. Now don't be afraid. A negative times a negative is positive. Then I have 2 times 4 is 8 over 7. It's okay. I'm going to subtract 1 from both sides, and I get y equals negative 2/7 x. Now, 1. That's the same as 7 over 7. So 8/7 minus 7/7 is 1/7. So I can just do it like that, because I knew that 1 is the same as 7 over 7. All right, so there's my equation. We have now arrived at checkpoint 2. Go ahead and pause the video, and this time you're going to write the equation of a line that's perpendicular to this one. So remember, you're going to solve for y first, because you can't take this slope out until you solve for y, and then you have to do two things to it to make it perpendicular. So good luck, we'll talk about that in class. All right, and finally number 6, an architect uses software to design a ceiling. And I know a lot of times at Purdue they're using really cool software for like the construction program. So this is pretty relevant now. The architect needs to enter an equation that represents a new beam. The new beam will be parallel to the existing beam, which is shown by the existing equation graph below. So this red line, we have to make a line that's parallel to that. And the new beam has to pass through 0, 10. So I have a point, which is 0, 10, that the new beam has to go through. And the slope is parallel. Well, we know that parallel slopes are what? Yeah, they're the same. So the slope has to be the same. Well, we learned way back in junior high how to find the slope from this graph. You just make the little triangle. It's rise over run. So rise over run. So my slope is 1 over 2. That's it. My slope is 1/2. Now, it wants it to be parallel, so that's the same. So I can go ahead and use this point for my x1 and my y1 and this slope. So I'm good. So here we go. Y minus y1 equals mx minus x1. I bet you have that memorized by now. So we have y minus 10 equals 1/2, and then x minus 0. I'm going to distribute my 1/2, but it doesn't matter because it's a 0. So then when I add 10 to both sides, I'm going to be finished. There we go. There's my equation, y equals 1/2 x plus 10. All right, I'll see you in class. Good job.